So system of particles and rotational motion. Correct. This particular thing. But before going to this, so we should first understand what is a rigid body. Correct. So rigid body in the sense that body, the shape doesn't change. The shape doesn't change. Correct. And it has a perfect shape. So it's perfectly definite. It's perfectly definite shape. Fine. And the most important thing which they can ask in the entrance is, correct. One thing is, suppose there is a particle in the, because this chapter name itself is system of particles in rotational motion, correct? So if the particle is there, correct, the distance between the particles of a rigid body does not change. So in a system, if there are any particle, for example, here there are system, one particle is here, one particle is here, one particle is here. The distance from one particle to another will be same. Fine. The distance between all those pairs of particles, fine, it remains unchanged. Then coming to center of mass. So that is nothing but force acting on the center. Correct. Force acting on the center. And it is mainly of translation motion. So one of the most important formula in this is, okay, so they may ask you to find the position or the position vector, correct? Position vector. So all are vector here. Position vector of the center of mass. So the moment you hear position vector, R vector, this is my position vector. R vector is always my position vector. Correct. So suppose if you don't know what is a position vector, so now if I'm extending this thing, okay, and then I'm joining this, then this is my R vector, the longest line, correct? That will be the longest distance, the diagonal one. It will be the longest line in that particular diagram, in that particular x-axis or y-axis, z-axis. If it's a three-dimensional, if it's a 3D, x, y, and z. If it's a 2D, x, y, correct? So R vector is always the position vector. So one of the questions is what is the position vector of center of mass? So that formula we have to study. So that is nothing but R vector is a position vector. I'll give M1 R1 plus M2 R2. Here I'm only taking x and y axis, two-dimensional thing. If it is more than that, it will be three-dimensional. I have to use one more thing, that's all. Plus M1 and M2. So here, what is my M1 and M2? M1 and M2 is nothing but the particles of masses. There are two particles. So if you ask me what is this M1 and M2, there are two particles of masses M1 and M2. Of masses M1 and M2 respectively. Correct? And their respective position is what? R1 vector and R2 vector. R1 vector, and they have two position vectors. Correct? That is R1 vector and R2 vector. And what is this? This is the position vector of center of mass. That is R vector Cm. Cm stands for center of mass. So this is one of the most important formula in this.